Today I'm going to talk about Guerrilla RF's cable TV offering. So we have a lot of different amps. We have 3 single-ended amps right now, and geez, I can't even keep the count of the push-pulls that we've designed. We'll go through them. Um, well, we'll talk about the GRF 9896. So there's two packages we offer. We offer 3 parts in a QFN, and the rest of them are in SOIC8. So the same 3 parts we offer in a QFN, we offer in a SOIC8. So the GRF 9896 is in a QFN. It's 3x3, and it's very small, good leadless package. But that was designed for the return path, very low noise figure. So you're talking um, about 2 dB at 5 megahertz, and around I'd say 10 to all the way out to 700, which the part was designed for the return path, so 5 to 700 megahertz. It has a maximum of about 1.3, 1.4 dB noise figure. So it's very high linearity. It's designed to be higher linearity than our competitors' parts. Um, and it is also capable of 1.2 gigahertz operation. So you can, and the gain's 25 dB, which is high as far as the first stage is concerned, and that as far as the return path is that's what's needed to actually overcome the diplexer loss and just maintain the noise figure. We talk about the GRF 9163. That is a 20 dB gain balanced amplifier that goes out to 2 gigahertz also. It's flat, high linearity, low noise figure. So we're talking like 1 point, I think when we're looking at the balun loss included, it's less than 2 dB at 1.8 gigahertz. So the gain, and it's a forward path part. So that would be it's designed to go down to 5. We have not tested it to 5, but it's designed to go down to 5, but we're speccing it from 50 to 2 gigahertz. It would be the GRF 91 or 9240, which is a 17 dB push-pull with up tilt. So it's got about 2 dB up tilt all the way out to 2 gigahertz. So it goes from 50 to 2 gigahertz. It's also fairly low noise figure, typically probably 2.3, 2.4 dB. They're very, very similar. So they are as good or better than the competitors when you go throughout the whole band. So we're talking typically 41, 42 dB output IP3, and typically say 68 dBm output IP2. So I mean, that varies throughout the whole range, and so. Okay, so when we go through the rest of the list, there's some that work up to 8 volts. And typically these parts are designed to work 5 to 6 volts. The single-ended parts are designed to work at 5 to 6 volts also. In instances that need higher voltage, we can explore that. The transistors are capable, the parts are capable, but there would have to be application circuits changes. But so the parts that we have are operational from 5 all the way to 8 volts. Some of them only go to 6 again, but there's a large part of them that can go to 8. So we can go the 7896 is just a SOIC8 version of the 9896, and it has the same performance. It's just a different package. The 7163 is an SOIC8 version of the 9163, and it has the same performance. And same thing for the 7240. It's an SOIC8 version of the 9240, which, I mean, same performance. So we have the 9811, the GRF 9811, which is a very high linearity, 16 dB gain part. That part is designed to go from 50 to 1800, but in actuality, I'm trying to get balance in. There's a good chance it can go all the way to 3 gigahertz. Right now, with the balance I have, I'm testing to 2.5 on that part. So we have up tilt on that, and there's about 3 dB up tilt from 50 to 1.8 gigahertz on that part. So that part is capable all the way up to 8 volts. So you can actually increase the P1s. So on that, most of our parts P1s, especially the balanced parts, are typically about 24 dBm to 25 dBm, and we have probably the single-ended parts are typically around 21 to 22. If you operate them off of 6 volts, then you can get 23, 24 dBm. The next one would be the GRF 9834. That is a lower gain part. It's designed to have lower noise figure than the competitors. I think the competitors' part is about 4 dB noise figure. This one actually has around 2.6 dB noise figure. It goes from 50, looks like it might go all the way out to the 3 gigahertz. Also has about 3 dB up tilt and is 8 volt capable. It's a extremely high linearity once you get into higher current levels. So you can change the bias. One thing I need to mention though too is that the previous parts that I was mentioning, all those push-pulls, they do have a bias adjust on them. You can operate it with and without a bias resistor and connect it up to the bias pin. The 9811 and 9834 do not have the capability of operating without the bias resistor. So, and the reason these newer parts were designed without the bias resistor connected inside was that provides better P1. Without having the bias circuit attached inside, you can get increased P1, output P1 on it. So it was specifically designed for that. And the plus side for this too is that if you can actually kind of shut the part down if you need to. You can put it in a low current mode. So, so the 90, I think I talked enough about the 9834. If you look, so there's different linearity ranges. So most of the push-pulls and the earlier ones were around 40, 42 dBm. The newer ones, the 9834, 9811, they're pushing 43 to 44 dBm mid-band. So they're designed for higher linearity. We have the 9297, which is similar to the 9240, but it's got about 18 dB gain, and it was designed to go out to 2 gigahertz also with slight up tilt, but for better P1s. It has slightly better P1s at 1800 megahertz. The next one I would like to talk about is the GRF 9897. It is another return path part designed for 5 to 700 megahertz. I think That one was tested out to gigahertz. It's good to a gigahertz, but that's a higher gain, slightly higher gain, 26 dB gain, but lower noise figure. So we're looking at typically about 1.6, 1.7 dB noise figure at 5 megahertz on that part. And that has about a dB higher output P1 than the 9896 or 7896.
Thank you so much for watching. If you'd like more information, please email us at sales@guerrilla-rf.com. And don't forget to subscribe to our channel for more content from Guerrilla RF.